Okay, so it's recording. Now, this kind of thing, what they've done here is there's not enough space to put all of this into one table. And it should be one table with the year as one column, and then the population as another column. And so they've split it up, but the years should go all the way down until the end at 2000. And the population starts at 76, which we understand that means 76 million, and then it goes down to 281. Okay. Now, they don't tell you to do this in this problem, but what you're going to have to do to solve this, to get the correct answers in the box, is you're going to need to change these actual years into t values. And of course, that's what we've been doing on this entire WeBWork thing and on this entire exponential and radio and decay problems. So we need to rewrite this. So here's the secret to this, and this is why I've put this in here. You want to rewrite this instead of a year, where your x value is a year. You want to start off where your time begins in the year 1900. So I'm going to replace that with a 0. And then for 1910, t is going to be 10 because it's 10 years after 1900. So I'm going to do this in my calculator now. So the way I'm going to start off in my calculator, and let me see if I can get this on the screen. I want to make sure it records. Let me clear. Press the stat button, and then go down to clear list and clear out list 1 and 2. So second button and 1, then the comma, which is right above the 7, and second and 2. Okay, and that's done. Then I'm going to press stat and then enter. And I'm going to come over here to list 1, and I'm going to put my t values in there. So my time starts in the year 1900, so that's 0. Then the year 1910 is t equals 10. The year 1920 is t equals 20. So we can see how this goes. Now 50, then 60, then 70, then 80, then 90. Then when I get to the year 2000 is 100 years after 1900. My starting time was 1900, so that's 100. Okay. All right, then I'm going to scroll over to list 2, and I'm going to put all my population values. So understanding that 76 means a population of 76 million. And just be very careful to enter those correctly because they don't have a pattern like the first list did. And 150, 179. And then I like to check them by going backwards. When I get to the bottom, okay, so if I scroll back up, 281, then 250, I'm checking them with my list. 150, 131. Okay, so I'm happy that that's correct. Okay, now let's see what this problem says. It says use a graphing calculator with exponential regression to model the U.S. population since 1900. Okay, so I'm going to do exponential regression. So you're told to do exponential regression. Okay, so that's what we're going to do. So I'm going to press the stat key, and I'm going to go over to calc, and I'm going to scroll down until I find exponential regression. Now it's not there on the main viewing screen, so just keep scrolling down till you find it. There it is, exponential regression. And I'm going to press enter. Now the default is list 1 and list 2, which is why I always like to put things in list 1 and list 2, because if you've defined it in list 1 and list 2, you just have to press enter on these older models. So I'm going to press enter, and it's going to tell me what my equation is. Okay. All right, so my equation is going to be, I want to write this as a function of t. So instead of y, I'm going to write it's a function of t. So my x values were my actual years, but I'm going to write instead, I'm going to use the letter t. So it's going to be a times b to the t. Okay. Now let's see what it said my a value was, and we want to take a to 4 decimal places. And so my a is 80.2131. 80.2131. Then times b, which I want to take to 4 decimal places, 1.0129. Okay, so this is my equation with respect to t. Okay, and this is what I'm going to use to answer these. And notice they give me the word million. Okay, so let me get this, let me get him just slightly out of the way. Okay, all right, so Part A wants to know the population in the year 1925. But see, I have a formula with respect to t, and my time began in the year 1900. So for the year 1925, I'm going to find this function f when t is equal to 25. And so I'm going to take that equation and I'm going to plug in 25. So I'm going to have 25 for my exponent. So I'm going to do that. Now I'm going to have to make that disappear off the screen while I do it in my calculator. So I'm going to have 80. Let me move that back out to the center. 0.2131. Then times b to 4 places to the power of 25. Okay. And that's going to give me to, let's see, and predict it. I wonder if they want it to the nearest million. To the nearest million. Okay, so the instructions right here said to the nearest million. Okay, so it's going to be 110.51 million. So to the nearest million, that's 111 million. Okay. And so if I come here, it should like it. Okay, it wants me to log in again. Of course. All right. So it's happy with that. Okay. If you don't change your actual years into t values, your calculator can't handle it and it starts rounding and it introduces rounding error. So this is the reason why you want to change it into a t value. Okay, so for the year 2010, well, your time began in 1900. So for the year 2010, that's going to be 110 years after 1900. So I'm going to do the same thing, but I just want this formula where t is equal to 110. And so I'll go back to this formula, but now I'm going to use 110 for my t value. So the same formula, but I want 110. Okay. All right, so in the year 2010, the population should be that, and that rounds to the nearest million, 329 million. Okay, and see how it likes that one. Oh, 320. Oh, hang on. What did I do? Go back. Did I do it the correct way? To 110. 328. I might, if it doesn't like your answer, okay, you might have to take it to more than 4 decimal places. So that's what I'm thinking. Let me go back, get the original formula. So never ever think that you're wrong or assume that you've done something wrong. It might be it just wants to see more decimal places. Okay, so it's given me that. Let's see if I take it to the year. If I take the thing completely as it is, and then times B, 2933432, and then take that to 110. Let's see what happens. Okay. All right. I'm going to get 330. Okay. So I said as a rule of thumb, take it to 4 decimal places. Sometimes that's not enough. If you want to be really safe, use the entire decimal string. If I'd taken it to 5, it probably would have been enough. Okay, so now if I round that, that's going to be 330. 330 million. Okay, so it should be happy with that. Okay. All right, so I'm not going to spend any more time on that one. The last one, the year 2020, well, that's just going to be putting t equals to 120 because your time started in the year 1900. Okay. What else could go wrong? If you make a mistake when you're entering your values here, just by one key off, that can make everything go wrong. Okay. But if it doesn't like your answer, go back and instead of rounding to 4 places, take the entire string. Or round to 5 places if it still doesn't take more answers. But I think that's the first time that I've rounded to 4 places and it didn't like it. Okay, and you saw when I rounded it, it rounded to 329, and it didn't like it. It had to be rounded to 330. Okay. All right. So I'm going to end